Here is the second video for section 4.2, and we're continuing with the law of sines, and we're still in that same set of directions where we need to find the all possible triangles for a particular situation. So we're ready for number 3, and just like I explained in the previous video, is that not ignore what the problem says, but change the letters so that angle A will always be given. So in number 3, angle B is actually given, so I'm going to change that to angle A, and therefore little b will become little a. And then once again, I don't care what the other side is, the other side will always be side B. And so we have the value of 25 here. And so we need to calculate h. H will equal b, which is 25, the sine of 112 degrees. And so we just take 25 times the sine of 112 degrees, and that is 23.1. So the first question we ask is A less than h? Is 2 less than 23.1? The answer is yes, and therefore, according to page 261, there's no triangles. And so if you don't realize that there's no answer, then you can continue to work. But there's no answer. You're never going to be able to get a correct answer, and so we're ready to go on to number 4. Number 4, we're actually given angle C, but once again, I'm going to totally ignore that, and I'm going to put it into angle A. So angle A is going to become 35, therefore C will become 16 point, or actually little a will become 16.1. And then it doesn't matter what the problem says, I'm going to make B the other side. So now it's time to calculate this. H is equal to B times the sine of 35 degrees, which equals approximately 10.7. So now it's time, first question we ask, is A less than H? 16.1 less than 10.7? The answer is no. Next question, is A greater than or equal to B? A is not greater than or equal to B, so we don't have one triangle. So now we just have two triangles. In other words, A has to be less than H. No, I'm sorry, A has to be greater than H, but A has to be less than B. Those are the two situations that are left, and what that means is there are actually two triangles, and so we will have to find both of those. So the first thing we're going to do is set up the law of sines. The sine of 35 degrees over 16.1 is equal to the sine of B over 18.7, which equals the sine of C over little c. First thing we're going to do is find B by combining this ratio with this one. Cross products will give us 16.1 sine of B equals 18.7 sine of 35 degrees. Divide both sides by 16.1. And then take the arc sine of both sides. And we're going to round to the nearest degree because we're talking an angle here. And so it's just a matter of plugging this into the calculator, and we see that that equals 42 degrees when we appropriately round. So now we can put 42 degrees here, Should be rather obvious that C is easily calculated as 180 minus the sum of the other two. Minus 77, which equals, let's see, 103 degrees. So that means angle C would be 103 degrees. And we can now combine this first ratio with this one to find C. So doing cross products, C sine of 35 degrees will equal 16.1 sine of 103 degrees. Dividing both sides by the sine of 35 degrees, and doing an appropriate rounding, which we're going to go to 2 decimal places because the most precise answer, our legs are in tenths already. So it'll be 16.1 times the sine of 103 divided by the sine of 35 equals 27.35. Now, that's all fine and dandy for one of the triangles. However, we now need to do the second triangle. And here we go. I'm going to rewrite what we knew from the beginning. Let's see, angle A was 35 degrees, A was 16.1, and B was 18.7. Now we had already calculated B as, let's see, that was 103 degrees. To find the second angle, or the second triangle, what we do is we take the supplement to that angle that we calculated. Well, we calculated it to be 103 degrees. And so the supplement of that, 180 minus 103, is 77 degrees. That is the other possibility for this particular angle. So that's how we get that. So then angle C becomes pretty simple to calculate as 180 minus the two angles added together, and that is 112. And so angle C in this particular case might be 68 degrees instead. Then the only ratio we really have to worry about is the sine of A with little a, and compare that to sine of C over little c, and then do the cross products to find little c. So C sine of 35 degrees will equal 16.1 sine of 60 degrees. Divide both sides by the sine of 35 degrees. And an approximation to 2 decimal places gives us 24.31. The final group of problems here deal with word problems, and so we will begin on this video and finish up on the third. Given a triangle with A equals 9, B equals 11, and angle A equals 31 degrees, what is or are the possible lengths of C? Round your answer to 2 decimal places. So the first thing we need to look at is this angle side-side situation, and the answer is yes. We have 2 sides and a non-included angle. So we're going to set it up in this fashion. A, B, and C. The angle is always A regardless of what it says, but in this case angle A is given. Little a would go there, and I don't care what the other side says, we're going to always make it side B. We quickly calculate h. H is always B times the sine of A. And so we take 11 times the sine of 31 and get 5.7. First question we ask, is A less than H? Is 9 less than 5.7? No. So that means there are triangles. Is A greater than or equal to B? The answer is no. And then finally, the only other possibility would be two triangles, which is where we are at. So we need to find two triangles, and it asks specifically what is the length of C. But in order to do that, we need to calculate the other values. So we have to go ahead and solve it all the way, because side C is the actual last value that we find. So it's not really saving us anything. It just may seem like we only have to find one. But in order to find one, we have to find the other two. So that's okay. Setting it up into the law of sines, we get sine of 31 degrees over 9 equals the sine of B over 11, which equals the sine of C over little c. Let's find angle B first. Cross products. 9 sine of B equals 11 sine of 31 degrees. Divide both sides by 9 so that the sine of B equals 11 sine of 31 degrees over 9. Take the arc sine of both sides. And after punching this all into the calculator, taking the arc sine of 11 sine of 31 degrees divided by 9, and rounding to the nearest degree, we get 39 degrees. Quickly calculating angle C, C would be 180 minus the 31 plus 39, 180 minus 70, which is equal to 110. So then we can combine this first ratio with this one. Cross products there, that would be C sine of 31 degrees equals 9 sine of 110 degrees. So C would equal 9 sine of 110 degrees over the sine of 31 degrees. And rounding to the nearest tenth, we get 9 sine of 110 degrees divided by the sine of 31 degrees equals 16.4. So that's one possible value for C. But now we have to deal with the other triangle. Now the other triangle is still going to have angle A be 31 degrees, side A 9 and side B 11. But now what we have to do is we have to find the supplement of angle B. Well, the supplement of angle B is 141 degrees, doing a quick calculation there. Angle C would then be 180 minus the two added together, or 180 minus 172, or 8 degrees. So then the only ratio we really have to worry about is sine of 31 degrees over 9 is going to equal the sine of 8 degrees over C. And then doing cross products here, C sine of 31 degrees equals 9 sine of 8 degrees. Dividing both sides by the sine of 31 degrees, and doing an approximation, or not an approximation, but rounding, we get 2.4. So the two possible answers are either 16.4 or 2.4.